Hello, welcome to this course on pattern recognition and applications. So, when we talk about the problem of pattern recognition, let us try to see what is meant by pattern recognition, or specifically what is meant by a pattern. So, if I draw a simple diagram, something like this, this is nothing but a pattern. Or if I draw diagrams like this, this is also a pattern. So, the problem of pattern recognition is given some signal, whether it is one dimensional signal or a two dimensional signal, we want the machine to recognize that particular signal. So, that is what is the problem of pattern recognition. Now, let us look at the origin of the pattern recognition problems. Pattern recognition, though we talk of pattern recognition problems these days, but the problem of pattern recognition is not that new. In fact, it started with in the early years with the effort of understanding intelligence. So, what is meant by intelligence? We can crudely define an intelligence as the ability to comprehend or to understand and profit from experience. So, what do I mean by that ability to comprehend and to understand and profit from the experience? Let us take a very simple example. Suppose I have a sharp object. So, if I take the tip of this pen, so all of you can see this pen. If I take the tip of this pen, the tip of this pen is quite sharp. Okay? Or even if it is sharper than this, say for example, the tip of a pin which is very sharp, and we know that if we touch or if we hit the tip of the pin, in that case this hurts our finger. So, that is what is our experience. And how do I profit from this experience? The profit is that whenever I come across such a sharp end, I will not try to touch it hard, because I know that it will hurt me. Similarly, if I take the example of fire, we know if I put my finger in the fire will burn my finger. So, that is the experience, and how I profit from this experience is that whenever there is fire, I will not put my finger into the fire. So, that is what is my experience. So, as I said, that the crude way of defining intelligence is to comprehend or to understand and profit from the experience. That is what is intelligence. Or we can also say that it is the capability and to acquire and apply knowledge. So, we should be able to acquire knowledge, and I should be able to apply the knowledge that I have acquired. Now, let me show you two different pictures. So, you find that I have two pictures in this slide. On the left, I have one picture, and on the right, I have another picture. So, if I ask you that can you recognize these two pictures? If we have seen it earlier, we will obviously say that okay, this left hand side, the picture which is on the left, it is nothing but a painting. To be more specific, if I know, I will say that it is wall painting in Ajanta caves. Similarly, if you look at the picture on the right, one will immediately say that this is picture of a building. But some of us who have seen this building or who have seen this picture before will say that this is the picture of Parliament House in New Delhi. So, some of us will be able to recognize it, and the question is, if we are able to recognize these pictures, then how do we recognize these pictures? Now, if I try to find out the answer to this particular question, that when I am able to recognize these pictures, then how do I recognize these pictures? The answer is not very new. In fact, we have to go back almost 2005 years ago, when Plato, who tried to give the answer to this, that how do we recognize objects, or how do we recognize pictures, or how do we recognize patterns. So, it is Plato in early days, I mean it was in 427 to 347 BC. So, you find that this is as early as more than 2005 years ago. And that time Plato said that the concept of abstract ideas are known to us a priori through a mystic connection with the world. Okay. So, if I write it, the concept of abstract ideas are So, you look at these two terms, one is abstract ideas, a priori, and in addition this is another term which is mystic connection with the world. So, again if you look at these two pictures, we said that if we know, we can say that this left hand picture is wall painting in Ajanta caves, and the right hand picture is the picture of Parliament House in New Delhi. So, how do we know it? In many cases, we have seen the pictures of wall painting in Ajanta caves in our school level history books. Similarly, some of us might have seen the Parliament House in New Delhi, or some of us might have seen the images or the photographs of the Parliament House in New Delhi. So, that means this information, or what I say is, in this case it is an abstract idea, because I cannot specifically say that why do I recognize this to be a painting in Ajanta caves, or why do I recognize, or how do I recognize this to be the image of Parliament House. So, this concept is actually an abstract concept, and I can identify this to be a painting in Ajanta caves, or the other one to be the image of Parliament House in New Delhi, because this information or this knowledge is already available to me a priori. So, what I am doing is I am making use of this a priori knowledge to recognize these two particular pictures. Okay. So, that is why these two terms, that abstract ideas and a priori, these are very, very important. And not only this, as I recognize a painting to be a painting in Ajanta caves, that means this information is embedded, or the image of that picture is embedded in my brain in some way. And what is that way? That is not yet fully understood. So, that is why it is said that through a mystic connection with the world. Okay. So, this abstract ideas of a priori knowledge are stored in our brain in a very, very mystic way. It is a mystery that how do we recognize or how do we store that information, or later on how do we retrieve that information to recognize certain things. Plato has also concluded that the ability to think is in a priori knowledge of the concepts. Okay. So, this a priori term is told by Plato in many ways. Now, let us look at another picture, say picture like this, right. So, if we ask you that what is this picture, you know that most of us have seen the images of a monument something like this, which is Taj Mahal. So, if I look at this picture, the immediate reaction will be this is the picture of Taj Mahal. Now, if I show you the next two pictures, where you find that the picture on the right is nothing but the picture that you have seen earlier, and the picture on the left, that is something different. So, when I show you these two, you will immediately say that the picture on the left is the picture of the Taj Mahal, picture on the right is not really the picture of Taj Mahal, but it is a monument which is very much similar to Taj Mahal. In fact, this monument is what is known as Bibi Ka Maqbara, and it is situated in Aurangabad, and which was built by Aurangzeb's son, but they are very much alike. So, you find that this a priori knowledge which has been told by Plato is not sufficient. We should be able to adapt our knowledge. That means, the learning that we have or the knowledge acquiring knowledge which we employ, that must be incremental in nature. So, as a result, Plato's student Aristotle which was in 384 to 322 BC. You see, it is before Christ, so almost 2005 years ago. So, Aristotle, who was actually Plato's student, he did not fully agree the concept of a priori knowledge which was given by Plato. So, what Aristotle said, that it is not only the a priori knowledge which is very important, but the ability to learn or to adapt to the changing world, that is also equally important. That means, we should be ability to adapt to the changing environment, and our learning process must be adaptive. That is, we should be able to learn new and new things, and we should be able to modify the knowledge that we have already acquired. So, what is the problem of pattern recognition in that case? So, as we have seen earlier, say these two figures, they may represent certain signal, they may represent certain structure, and so on. So, the problem of pattern recognition is to identify the underlying structure within a data. Okay. So, if I have a given set of data, I want to identify the structures within that data. And what are the structures that I want to identify? It is the structures which are known to me a priori. So, that is what is the pattern recognition problem. So, we can define crudely the pattern recognition to be the search of structure in the data. Okay. So, that is what is by pattern recognition. Now, why do I want this pattern recognition? What is the importance of pattern recognition? I want this pattern recognition so that I can impart certain power to a machine, so that the machine can work in the same way in which I can do work. Okay. So, I want that the machines should be equally intelligent as a human being, and whatever work that we do, a machine or a computer should be able to do the same things. Okay. So, what are the different approaches of pattern recognition? So, in this introductory lecture, I will briefly tell about, or I will introduce the pattern recognition problem, then I will talk about what are the approaches of the pattern recognition problems or to solve the pattern recognition problems during this course of pattern recognition and applications. Now, coming to the application side, the pattern recognition problem or the pattern recognition techniques have applications in various domains. For example, take for example the medical signal analysis. Okay. So, each of us have seen that whenever a doctor or a medical practitioner have any doubt about the functioning of heart, whether our heart is functioning properly, they prescribe us to go for ECG checkup. Okay. And all of you know that when you get an ECG pattern, the ECG pattern appears something like this, and it is a repetitive pattern. Okay. So, this is nothing but a structure. Okay. So, what the doctors do is they look at these patterns, and by looking at these patterns they try to judge whether our heart function is proper or there is some abnormality in our heart function. So, this is just one of the example how the pattern recognition is very useful. Similarly, we can have the application of pattern recognition in speech recognition or in speaker recognition. Okay. I can easily recognize voice of Hemant Kumar, I can easily recognize voice of Lata Mangeshkar, I can easily recognize voice of Asha Bhosle and all those different people. But all of them are singing. So, which is nothing but an acoustic signal, because it is sound wave, it is nothing but an acoustic signal. But how do we, from those acoustic signals, how do we recognize the voice of different persons? So, that is what is speaker recognition problem. Similarly, I can have speech recognition problem. Okay. So, you might have heard about tools like speech to word conversion. Okay. So, that speech to word conversion tool is nothing but whatever I am speaking, there is a machine which captures the voice, okay, and which is converted into an electrical signal, processes that electrical signal, extracts certain properties or called features, which I will come to a bit later, and based on those features, the machine tries to extract that which word I have uttered. Okay. And it is the same concept which is also used whenever we go for speaker recognition, because whenever I speak or I try to sing a song, though I am not a singer, and whenever Hemant Kumar tries to sing a song, there is clear distinction between my voice and the voice of Hemant Kumar. So, we can have signal processing techniques to extract those properties or those features from the speech signal, and using those features we should be able to recognize whether the voice is from Hemant Kumar or it is the voice of somebody else. Okay. So, similarly, in case of machine vision, if I have an automated assembly shop where we want that every operation has to be done by a robot in an automatic way. So, the robot must be capable of seeing what is there in the shop floor. That means, the robot must be attached with a vision system, maybe a digital camera. So, digital camera takes images of the shop floor. From those images, it locates different objects, and locating different objects is not sufficient. It should also be able to recognize which object is what. Okay. And based on that, it can pick up certain objects and fix that object in some specific position. So, there also your pattern recognition or object recognition, because objects are also nothing but patterns. So, pattern recognition or object recognition is very, very useful. So, this problem or the domain of pattern recognition problems is quite wide. The pattern recognition is applied in various applications, whether we try to recognize the patterns into one-dimensional signal or we try to recognize patterns in two-dimensional signal like images. Now, when I go for such pattern recognition, the pattern recognition can be done in one of the two ways. One of the way is called a supervised learning, and the other approach is unsupervised. Though the problem domains are slightly different. So, now let me just illustrate what is meant by supervised learning. Let us take few objects. Okay. So, this is a set of objects, all of you know what these are, and I have another set of objects something like this. Okay. So, if I take the images of these two sets of objects, they are nothing but patterns. Okay. And these patterns are to be known a priori, coming to what Plato said, that I have to have an a priori knowledge or a priori information of the objects that I have. And how do I have that a priori information? All of you know that this is nothing but an USB drive, sometimes called pen drive, which is used to store data. Okay. So, I know that this class of objects or this class of patterns are nothing but USB drives or pen drives, which are used for storage of data or storage of program or taking backup from a computer. Similarly, here I have another set of objects or another set of patterns, and I know that these are pens with which I can write. Okay. So, these are two sets of patterns, and the knowledge of patterns I have a priori. And how do I acquire this knowledge? Acquiring this knowledge is not a one-day process. This knowledge has been acquired over the time, starting from my childhood. When I started writing A, B, C, D, my mother used to take a pen and she used to tell me that with this you can write and this is how you can write. So, you find that starting from our childhood, we have started learning patterns, and that is what is a priori knowledge. Then when I grown up a little bit, then I started using these things, USB drive. And there also my teacher or my friends who have used it before must have told me that these are USB drives or pen drives with which you can take your data backup or with which you can take your program backup. And then I have started using these USB drives. So, along with what Plato said, that abstract concepts are known a priori, and then what Aristotle says, that these concepts that we are learning, the learning must be incremental. That is, in the childhood I have learnt about pens. When I grown up, I learnt about these USB drives. I did not use USB drives when I was a child. So, I am acquiring this incremental knowledge. So, you can easily see that the pattern recognition problems that we are talking about today, this is not really a recent problem. The problems were thought of, those were analyzed by the philosophers as early as more than 2500 years ago. Okay. So, now let us come to our problem, that when I have these two sets of objects, now if I put this object, I know that the similarity of this object with these sets of objects is more than the similarity of this object with this set of objects. Okay. So, as a result, I will recognize this object, which is now an unknown object, to be a pen, not to be an USB drive. So, this is what I mean by supervised learning. So, in case of supervised learning, I have to have a priori knowledge, and when I get this a priori knowledge is acquired through experience, through observation, through instruction, it may be many ways. And during classification, if I am shown an unknown object, then that unknown object has to be put into one of the known classes which are known a priori based on the similarity measure. Okay. So, when I try to classify this object to be a pen, effectively what I am doing is I am trying to find out the similarity between this object and these two sets of objects. And I compute that the similarity of this object with this set of objects is more than the similarity of this object with this set of objects. So, I recognize this object to be a pen, not as an USB drive. And this is what is supervised learning. So, in case of supervised learning, I must have a priori knowledge, and that a priori knowledge may be acquired through experience, through observation, through instruction, it may be many ways. Okay. And I apply that a priori knowledge to recognize or to classify an unknown object or an unknown pattern. So, this is what is our supervised learning problem. Now, the other category that I said, which is unsupervised learning. In case of unsupervised learning, nothing is told a priori. Okay. So, what I have is I have a mixture of all these different objects, right. The problem is something like this. I have a mixture of all these different objects, and from this mixture I have to separate the objects into two or more groups. So, what I will do is I will try to find out the objects which are similar and put them into one group, and objects which are not similar to the objects belonging to that group will be put in other groups. So, over here I will simply put these objects into one group because they appear to be similar, and I will put these objects into another group because they appear to be similar. So, what I had initially is a set of objects for which I do not have any a priori knowledge, and what I am doing now is I find out every pair of objects which are similar, and the objects which are similar are put in one group, objects which are dissimilar are put in different groups. So, doing that, if I take any two objects from a group, they must be similar, that means they have high degree of similarity. But if I take an object from one group and another object from another group, they must be dissimilar, or the degree of similarity may be very poor. Okay. So, this is a one for which I do not apply any a priori knowledge, is what is known as unsupervised learning, that is what I said. So, whenever we talk about such pattern recognition problems, the pattern recognition problems are categorized into two different types. One is supervised learning, other one is unsupervised learning. In case of supervised learning, we have a priori knowledge of the pattern, or we have a priori knowledge of the objects, and using that a priori knowledge, I want to recognize, or I try to recognize or classify an unknown pattern or an unknown object. In case of unsupervised learning, I have a mixture of objects, I do not have an a priori knowledge, but from that mixture of objects, what I do is I partition them into different groups, where objects within the same group and similar are similar, and objects belonging to different groups are dissimilar. So, I have to have some sort of similarity measure. Now, again I come back to what Pluto said, that the a priori knowledge is embedded in our brain in some mystic way. It is really a mystery that how the information is actually embedded or stored in our brain, and how do we retrieve that information to recognize an object. Now, you think of our purposes that I want to impart the same level of expertise or the same level of intelligence to a computer or to a computing machine, so that the computer can work the same way in which I work, or the computer should be able to say that this is one object, this is another object. Though as a human being, this is pretty obvious to me. I will simply say that these two are not same, they are different. This is a pen, whereas this is an USB drive. But our challenge is that how do we want or how do we expect the computer to do the same thing, computer to solve the same problem. So, all of you who have knowledge of computer programming or writing algorithms, you know that if I want the computer to do the same operation, then I must have some description of the objects or the description of the patterns. Okay. So, this object should have some description, this object should have similar description, and the description or the instance of the description for this object and the instance of the description for this object, they should be different. And this is this description what I am calling as feature. Okay. So, what are the different types of features that we can have? So, in this course, initially we talk about the feature extraction. So, our first topic of this pattern recognition and application lecture series will be feature extraction. So, what is this feature extraction? So, for example, if I take this device, this USB drive, and if I take this pen, you find that if I draw the boundary of these two different objects, the boundary of this object will be something like this. Similarly, the boundary of this object will be something like this. Right. So, you find that there is clear difference in the boundary. So, I can have the features which are derived, which are extracted from the boundary. Not only boundary, both these objects have a region which is bounded by the boundary. So, this is the bounding region of the USB drive, and this is the bounding region of the pen. So, I can have features from these bounding regions also. So, accordingly, when I talk about features, the features are usually of two types. One type of feature is known as boundary features, and the other one is known as region features. So, boundary feature is the feature or the set of features which can be derived, which can be extracted from the boundary of the object. And it has been argued that whenever it comes to a shape of an object, most of the information is actually available onto the boundary. Okay. And whenever we cannot discriminate among different objects or the different patterns using boundary information only, then we go for region features which are obtained from the region enclosed from the boundary. So, what are the boundary based features that we can extract out of it? What I can do is, I can have this boundary in the digital domain is nothing but a set of points. Okay. So, what I have is, if I draw it in a 2 dimension, or objects are actually 3 dimensional, but I can illustrate that with the help of 2 dimensional figures. So, this boundary is actually nothing but a set of points in a 2 dimensional space, something like this. So, when I have a set of features like this, I can assume this horizontal axis to be my real axis and the vertical axis to be an imaginary axis. So, given this, every kth point in this boundary can be represented by an complex number, say S k, which is nothing but u k plus j v k. And I have all these different points for different values of k. So, what I actually have, if I start scanning this boundary from any of the initial point, what I will have is a set of my complex numbers S k, where k varies from say 0 to capital N minus 1. If I have capital N number of such boundary points. So, you find that it is nothing but a sequence of such complex numbers. Then one of the ways in which a feature can be extracted is that I have a sequence of complex numbers. What I simply do is take the first Fourier transform or the discrete Fourier transform of this sequence of complex numbers. And when I take the discrete Fourier transformation, as I have capital N number of samples, complex samples, I will have capital N number of discrete Fourier transform coefficients. And the magnitudes of those capital N number of discrete Fourier coefficients itself can describe this particular boundary. So, that becomes a set of feature. So, there are various other ways, this is just one example, there are various other ways in which the feature can be extracted. One of the ways can be that when I have such a boundary, I may like to find out the moment of this shape around say principal axis. I find out the moment of this shape around this axis, and I find out the moment of this shape around another axis which is orthogonal to the principal axis. So, I get two components. One is moment around the principal axis, the other one is moment around an axis which is orthogonal to the principal axis and passing through the center of gravity of that particular shape. So, I get another set of features, and this is what is shape feature. So, I can have boundary feature, I can have shape feature. Coming to the regional features, the bounded region will have certain color, it can also have certain texture. So, I can extract the color property which I can call color feature, I can find out, I can extract the texture property which I can call texture feature. So, this particular object now have different types of properties. A set of properties are computed from the boundary, a shape of properties are computed using the shape information like moments, a set of properties from the color, a set of properties from the texture and so on. So, all these different features actually give me different numerical values. Okay. And if I put these numerical values in a certain order, each of the numerical values gives me some information of this object. And when all these numerical values are put in a certain order, what I get is a vector, right. So, every individual component is a feature, and all the features taken together in a particular order gives me what is called a feature vector. Right. So, you find that now the objects or the patterns are represented by the corresponding feature vector. So, whenever I have such a vector representation of an object or a pattern, my classification becomes very simple. Okay. How does it become simple? Because if the components in my feature vector are say capital M, that is every pattern is represented by an m dimensional vector. Effectively, what I am doing is I am transforming the pattern or the object from its spatial domain or time domain to another space which is a feature space. And because these feature vectors are m dimensional, so what I have defined is an m dimensional feature space. For simplicity, because I will be drawing on the paper, if I assume the value of m to be 3. So, if I assume m is equal to 3, that means I have 3 dimensional feature vectors. For every pattern, I have one 3 dimensional feature vector. Then what is my advantage? Advantage is whenever I have such feature vectors of say dimension 3, what I am effectively doing is I am representing my pattern in a 3 dimensional space, which is nothing but feature space. So, this is my feature 1, let me call it x 1, this is the dimension of x 2, this is the dimension x 3. So, a pattern P 1 will be represented by a vector say something like this, say 3, 5, 1, which is the feature vector corresponding to pattern P 1. And the moment I have this 3 dimensional feature vector, this 3 dimensional feature vector is nothing but a point in my 3 dimensional space, which may be say somewhere over here. So, this is the feature vector corresponding to my pattern P 1. Similarly, I can have a point P 2, which is again represented by a feature vector say f 1, f 2, f 3. What this f 1 will have certain numerical value, f 2 will have certain numerical value, f 3 will also have certain numerical value. And this pattern P 2, once it is represented by such a feature vector, this pattern P 2 will also be a point in my 3 dimensional feature space. Now, we look at the advantage that once these patterns are represented in the 3 dimensional feature space, I can measure the similarity or dissimilarity between these two patterns P 1 and P 2 simply by taking the distance between these two feature vectors. If the patterns P 1 and P 2 they are identical, that means this P 2 and this point P 1 they should be coincident, that is f 1 should be equal to 3, f 2 should be equal to 5 and f 3 should be equal to 1. Or in other words, the distance between P 1 and P 2 should be equal to 0, if P 1 and P 2 are the same pattern. If P1 and P2 their similar pattern may not be exactly identical, in that case the distance between the corresponding feature vectors, when I compute, the distance should be very small. If P1 and P2 they are widely different, there is no similarity between P1 and P2, in that case the distance between the corresponding feature vectors in the three-dimensional feature space will be very large. So, if the distance between the feature vectors is small or negligible, we can say that those patterns are similar or they are the same patterns. Slight difference in the feature values may be due to measurement error, may be due to fabrication error, but the patterns are same. If there is no error, then the feature vectors must be identical. So, I have different sources of error. I can have measurement error, I can have fabrication error, all these different types of errors may come in, which does not make the feature vectors identical, but the feature vectors should be very close, that is the distance between the feature vectors are very small. So, I can have a measure of similarity, I can decide whether the patterns are similar or the patterns are not similar from the distance between the corresponding feature vectors. If the distance is very small, then they are similar. If the distance is very large, they are not similar. So, this is my simple tool. Now, let us assume that this point P1 and this point P2, they are patterns of two different classes. Okay. They are patterns of two different classes and these two patterns are known a priori. So, this point P1 may come from a class C1 and this pattern P2 may come from class C2. And now, my job will be that given an unknown pattern, say P, where this P is also represented by a similar such feature vector, something like this, say x1, x2, x3. So, my job is that I have this a priori knowledge of P1 and I have this a priori knowledge of P2. I know P1 belongs to C1, P2 belongs to C2. So, my job is that given now an unknown pattern P, I have to recognize this pattern or I have to classify this pattern. So, one simple classification rule can be that because I have these two known patterns P1 and P2, I find out the distance from P1 to P, I find out the distance from P2 to P. So, what I have to do is I have to find out distance between P1 and P and I have to find out distance from P2 to P. So, if I find that the distance from P1 to P is greater than distance from P2 to P, that means P1, this unknown pattern P is more similar to P2 than to P1, because the distance between P1 and P is more than the distance between P2 and P. So, this unknown pattern P is more similar to P2 than it is similar to P1. So, my simple classification rule can be that I will classify or I will recognize this unknown pattern to be a pattern belonging to class C2. It will not be a pattern belonging to class C1. Okay. So, during our course of lectures, initial few lectures we will devote for different types of features and different types of feature extraction techniques. And the next we will talk about different types of classification problems. Now, the moment I have come for this classification, we said that we want to represent every pattern by a corresponding feature vector. So, once a pattern is represented by a feature vector, whether it is a temporal pattern like speech signal or the signal coming out of any other source, or it is a spatial signal like image or video. Video is of course a spatio-temporal signal. because I have different number of frames. The frames are played at a certain rate, so 30 frames per second, 25 frames per second and so on. So, images are spatial signal, speech signals are totally temporal signals, videos are spatio-temporal signals. I have spatial variation, variation along the space, I have also variation along time. So, those are actually spatio-temporal signals. Now, whatever type of signals or whatever type of patterns I have, once I convert the pattern to a feature vector, my classification remains the same. Because what I have to do is, depending upon my application domain, I have to train my classifier so that it can work in that particular application domain. So, what I can do is, I can put this pattern recognition problem in a block diagram something like this. So, I have a pattern recognition or a pattern recognizer, let me call it as PR. Input to this pattern recognition system will be my feature vectors. So, these are feature vectors. And output of the pattern recognition system will be the decision about different classes of this input feature vector. And when I have this pattern recognition system, this pattern recognition system must be trained or learned by a supervised learning approach. So, for supervised learning, what I have to do is, I have to input a set of feature vectors or different sets of feature vectors. For different sets, I must know what class, from which class that particular set of feature vector has come. So, that is what is supervised, and based on that information, I have to train this pattern recognition system. And once the pattern recognition system is trained, then given an unknown feature vector, I should be able to say, or this pattern recognition system must be able to recognize to which class this feature vector should be classified or it should belong. Now, given this sort of a block diagram, you find that this sort of pattern recognition system can now be applied in any domain. It can be used for speech recognition, it can be used for speaker recognition, it can be used for object recognition, it can be used for image classification. Now, what I mean by image classification? I can have images of different types. I can have indoor images, I can have images of natural scenes, I can have images of a shop floor. Okay. So, if my pattern recognition is properly trained after properly finding out the feature vectors, then this pattern recognition system can be used to recognize or to classify patterns from any domain, right. Of course, the pattern recognition system for speech recognition is different from the pattern recognition system for object recognition, because the domain knowledge is different. My representation of the feature vectors will be different. So, in this particular course, what we will talk about is, initially we talk about the different techniques to extract the feature vectors, what are different types of feature vectors that can be used, what are different techniques to extract the feature vectors, and then we will go for different pattern recognition systems or different types of classifiers. Some of the classifiers make use of statistical properties of the signals, or the feature vectors are used using statistical property. Then we can have probabilistic models of different classes, making use of mean and variance of the feature vectors, okay, which we will talk about when we talk about something called Bayes rule. Which is used in statistical classification or statistical classifier. So, there again we can have two different forms of classifier. One form of classifier is called a parametric classification technique, another form of classification is called a non-parametric classification technique. So, in case of parametric classification, whenever I have a statistical model or probabilistic model of a particular class, we will assume that the probability density function will have a parametric form. In the sense, say for example, a Gaussian probability density function which has two different parameters, one is mean, other one is variance. When I have feature vectors of multiple dimensions, I will have mean vector and covariance matrix. So, which are the parameters of probability density function if I assume the probability density function to be Gaussian? But in most of the cases, it may so happen that the probability density function which is exhibited by the samples, they do not follow any particular parametric form. So, I will have different types of non-parametric classification techniques. So, we will have parametric classification techniques, we will have different types of non-parametric classification techniques. Then we will also have other types of classification techniques, say for example, neural network, many of you might have heard about it. Neural network is an attempt to build machines which can imitate the functioning of our human brain. Okay. So, we will also discuss about different types of neural networks which can be used for pattern recognition or pattern classification. We will talk about another type of pattern recognition or pattern classification which is called hyperbox classifier. Then we will also try to combine hyperbox classifier with the fuzzy measure, and later on we will combine our hyperbox classifier, fuzzy measure and neural network to have certain model called fuzzy min max neural network. So, that is another type of tools, fuzzy min max neural network, that can also be used for pattern recognition or pattern classification. We will also talk about something called support vector machine. So, what the support vector machine does is, it defines a plane in my feature space. So, using that plane, I can divide the space into two half spaces. So, in one of the half space, I will have patterns belonging to one class, in the other half space, we will have patterns belong to some other classes. So, the support vector machine actually tells you that given a set of training features or the training feature vectors, where to put this plane or this hyperplane, or how to subdivide my feature space into two subspaces, so that my classification, when I go for classification, I can attain minimum error of classification. So, all these different types of techniques for pattern classification we will talk about. Then later on, we will also talk about classification of temporal patterns. Say for example, if I simply put my hand like this or my palm like this, it is just a palm. But it is not sufficient. If I simply wave like this has certain meaning. Okay? If I put it like this, it has some other meaning. So, simply showing a palm is not sufficient. It is also important that how the palm moves over time, because that carries certain meaning. So, it is a temporal pattern. So, we will also talk about how to recognize or how to classify such temporal patterns. So, these are the different techniques that we will be talking about during this course on pattern recognition and applications. So, in the next class, we shall start talking about the feature extraction techniques. Okay. Thank you.